Well, which specific model to pick? I don't know. There are so many of them. This design was produced at different factories with different finishes. But overall, the loudspeakers themselves are the same. The calculations and internal volumes are about the same. The best ones even have left and right versions. But overall, if you look at different publications and videos about the S-90, most of them focus on how bad it is. Yes, by modern standards, both the tweeter and the mid-range are bad. Really, they're bad, I agree. But on the other hand, how could so many of them have been produced? There must have been something done right about them. I would say the key things are that its design allowed it to be placed in the corner of a small room, and it would still sound good without booming. And secondly, because of its size, you could use it at any event during your teenage years. Me too. I was a teenager when one of my classmates got these speakers. No matter how much we carried them around, they were always there. These weren't even the S-90s, those didn't have any grills, so it was risky to carry them around. And then, when they came up with the grills, it became this portable thing for dance parties. You could get decent sound in a pretty big room, and that's how it was used. Many of these speakers we see are all scuffed up. It's not like someone was carefully examining them in the corner. Teenagers were dragging them from one place to another, and it held a certain cult status back in the 70s and 80s. It was produced in huge quantities. There's even a number that's sometimes mentioned, 5 million. At all the factories, everywhere they were produced, under different names, but basically the design was essentially the same. For demonstration, we bought a pair of speakers, something like this, with metal protective grills and a single switch, and we are going to convert them into an active system. To refresh my memory, I looked up the history a bit, and they were created in 1977. Well, we were trainers there, and that's what the first one looked like. This isn't the S-90, it's the 35 or S1, but basically all the others were similar. The designs were very similar to this one. Later, other designs and features appeared. What makes this development unique? Before this speaker, basically all speakers were made as full range, and all the developments were full range. This is the first speaker where the frequency bands were separated. It immediately raised the quality to a new standard. So the authors of this project are Kerner Rollins and Latsis Sinters, two engineers who made this key development. Also, the modern ones I looked at, different S-90s, basically repeat this development. Originally, there was a large isolated compartment for the tweeter and the mid-range. Then the mid-range had a long tube like this. And this was in the shared enclosure volume. The volume improved a bit or became a bit larger. Then this bass reflex or port also had several variations. There were 80 millimeters, 100 millimeters, and different lengths. In general, there were a lot of modifications, but overall the design remained the same. But here the initial parameters are basically better than what was later developed and produced on a mass scale. Later, in mass production, I think it was 35% here. And here it was from 1 to 3. Well, even by today's standards, this is a more or less decent speaker. Yes, the distortion is a bit high. But today, the average loudspeaker has about 1% distortion, maybe a little lower, like 0.5%. There are some really good loudspeakers that go down to 0.1%, but overall, we haven't gone that far from all of this. Repeatability is better. All today's developments have better repeatability. Well, mostly today's consumer, of course, says bad things about this development. But when we bought this old sample, I connected it to a good amplifier, a proper 500 watt powerful amplifier. It drove them well, but there was some problem with the mid-range. We'll see later how this shows up. In general, a patent was obtained during this development, and then there were several more throughout the whole project. But this is the first patent, and I even looked at what this patent is about. I'll be honest, I didn't find it right away. It took some time. Anyway, I found it. There is such a patent issued on January 15th, 1978, such and such, such and such. Here are both inventors. And what do they write about there? Well, basically, I figured out it's something with the bass reflex. They did something with the bass reflex so that it rumbled less. That's how I understand this patent overall. At first I thought the whole crossover would be patented, but no, it's some kind of thing in the port or the principle of the port. It's hard to say. Well, here's the description, but I don't know what it is. The system is distinguished by the fact that the sound absorber is fixed on a rigid holder inserted into the bass reflex port. Sound absorber. Well, basically they developed this 35AS1. Yeah, I remember a guy had ones like that. His father bought it and we took it to different events. So for our experiment we bought one like that. We bought it for 150 euros. What? Well, let's take the speaker apart. We won't drag it out for too long. All the screws go in the box. Well, they saved on wires here to make them shorter. We're taking this apart mercilessly. We won't use any of these wires. We'll just cut them off and that's it. What am I going to use from this? I'll use this gasket. It's good and seems just right to make a seal here. Yeah, we'll keep this one. The loudspeaker, well, if we don't throw it away, we'll give it to someone whose speaker burned out. Well, you can even see here, if you look closer, you can tell someone poked the tweeter with their finger. Well, that's easy to fix, but the speaker suffered. Probably some little boy or girl couldn't resist. Well, the same thing. Mid-range. Well, here we have a damper. That's all. Everything's fine. We'll use the same one later. It's more complicated with the woofer. I'll remove all attachments. Well, I'm curious how they actually came up with this design solution because the design is successful, really successful. And this speaker, which came from that 90s style or production, started working as the heart of small dance parties, small gatherings. I used to carry those around later too. When I was a student and had a bit of money, I bought those too. I had ones like that. That was the period when I owned speakers like that. Then in the 1990s I sold them. But notice that this speaker also doesn't have a seal. And considering how well the rubber has been preserved, maybe someone modified it, rebuilt it, or replaced it. Overall, the suspension is in such good condition. The woofer is perfect. All in all, the purchase was a success. Since the woofer is in good condition, we're golden. We can make various modifications because we're going to throw out the mids and highs anyway, even if they're in perfect condition. Yeah, everything's fine here. Basically, I got lucky. Clearly, I was lucky with this purchase. So the 150 euros I spent paid off. Overall, it's good. Or you can also check around the edges by pressing. If it doesn't rub, that means they did a good job too. Overall, this one is perfect. Really, it's very good. Lucky. It seems these speakers have been through a lot. And they've been repaired and modified. Ah, well, it wasn't that difficult after all. Well, you'll have to solder the wires. There's no other way. Thank you. The manufacturing date can't be determined. But it looks brand new. All in all, we got lucky with this woofer. We'll use felt for damping. We won't use anything else. Ah, they're glued on. One of them is glued on. That way, everything looks neat. to the edge. I'll do it exactly like that later. Actually, I don't even need to take this one out. I don't need this one. Let it stay. But I'll take out the crossover. It takes up way too much space here. And I really am thinking about how to improve it and try to show the difference when it's in active mode and how it works through the crossover. But I'll need to tinker with the crossover, of course. Here everyone was saving on a single screw. Sloppy work, guys, sloppy work. There should be 4 screws. Someone didn't want to put in the effort. Typical Soviet hack work. The second speaker had all 4. Well, here's the crossover. Clearly they used what was available. Well, obviously they suffered from the fact that components were unavailable. They used whatever they had and combined things. Basically, the number of variations here is limitless. But these paper capacitors, they're pretty good. They all still measure within spec. I measured them, they're like new. All of them are like new. And actually, these capacitors, if you buy, say, Mundorf or some ridiculously expensive ones for low frequencies, they're quite suitable. We can change something in the high frequencies. But overall, yes, they're large in size, so they look a bit strange. But overall, it's a good capacitor, and you get a good crossover if you use them. Let's leave it. We'll improve it in the summer. This is the back panel. Let's try. Let's try to see what year it is. It's from December 1984, so it's relatively new. The price is 150 rubles. Well, considering that it was about the average salary of an engineer, somewhere between 150 and 200. Well, if you convert it to today's money, well, nowadays our engineers also get about 1,500 euros up to 2,700 depending on their qualifications. Well, that's a full monthly salary. You know, the speaker cost, well, about 1,500 euros. Can you buy an S-90 or something similar to the S-90 today for 1,500? Yes, you can. The price is about the same. Linton Wharfdale, you can get a pair for around 1,200 euros somewhere. Well, I mean, with an 8-inch speaker, well, that's basically the same as the S-90 today. We even bought it with the manual. Warranty card and so on and so on. Well, all the seals were broken off, of course, from this one. Look, there's even a diagram. Filters are included. A 4-ohm speaker. Look how many capacitors there are here for the low frequencies. These are those expensive paper ones. Capacitors were used. Overall, I would say the crossover is relatively expensive. What does it look like? Here's the kind of internal crossover in this speaker. Well, as we can see, here are these banks of capacitors. There are 4 here. And why are they different? Different colors? It's hard to say. All of them are 20 microfarads each. Why are the colors different? I don't know. Probably they just used whatever color they had. Or maybe they have differences, I don't know. So basically here it's 20, 20, 20, 20. So that gives us 80 microfarads. Well, the schematic says it's 110. There are some differences. This device can operate at a slightly higher level. Well, overall, from the filter's point of view, it's good. So air core coils throughout, including the low frequency ones, don't saturate. 0.8 wire for 35 watt speakers. Well, okay, for 100 watt speakers. Everything is quite decent. All paper. I measured the capacitor's rating. It holds up completely. And they are quite accurate. So this filter is in perfect condition. In perfect condition, there are no electrolytic capacitors drying out or anything being lost. In general, this crossover can be slightly modified. For example, you can replace it with a mid-range tweeter. You can even make a passive speaker out of it. Maybe I'll work on these sometime in the summer, but it takes a lot of time. Although I'm a firm supporter of fully active speakers. And we throw out all the crossovers. We install it today. Even today, inexpensive TPA 3255 amplifiers can fully handle this design. Before starting, I disassembled the first speaker and completely rebuilt it to make sure everything works. All the adapters fit and so on and so forth. And I want to show you why these speakers are so old, why you need to replace these. All the loudspeakers, look here, this is a mid-range driver, right? And basically it's done for. Its parameters have drifted. As you can see, the rubber is cracked. It needs a complete overhaul, but as you understand, there's no point in fixing anything here. If you can buy the most modern one there for 50 euros, even an average one will work really, really well. Well, if you want to see Soviet-style work, just look at how the glue is applied here. Well, they could have put it on some kind of rotary stand and used a dispenser to apply everything neatly. There's no need to smear it like, I don't know, with a brush, yeah. It's very difficult to determine the manufacturing date. It's impossible here. Actually, what's wrong with this loudspeaker? The thing is, because this S-90 turned out so well, someone issued an order that everyone would make this kind of loudspeaker and this kind of speaker system. And as a result, all development of loudspeakers basically stopped. I wish I could see that bureaucrat who basically killed all the development of loudspeakers. Everyone was making just these. Well, the tweeters were there, but they were lousy. That's a fact. They were objectively lousy, so they definitely need to be replaced. And it's hard to replace them because back then the tweeters were 16 ohms. And it's hard to find a 16 ohm tweeter today. If we put a 4 ohm or 8 ohm tweeter in there, we have to redo the crossover. And that's relatively expensive. But this big thing can handle it. It's hard to say. 10 watts and that, this small modern 100 watt one. How far the whole technology has advanced. And back then it cost 15 rubles. By today's standards, that's about 160 euros. This one costs 50 euros. No, this one I think is even 35. Yes, 35. It's totally crazy over there. But it's good, it's really good. When they brought me these speakers, of course, I hooked them up and listened to them. And overall, they could probably handle, I don't know, a drunken party. Yeah, you could easily play them in the background. The bass was just fine. But if you really listen to music, there was actually some kind of weird anomaly in the upper mids. Somewhere around 3 kilohertz. If a piano was playing, you could hear that something was off. It sounded a bit harsh. The upper registers of the piano or grand piano sound clean. And it was so noticeable that I even took a measurement microphone and checked how it looked. And here I recorded the frequency response. Well, in my room, you can trust it from around 350 on, roughly from this point. But you can see that at 3.5, 4 kilohertz, there's some serious issue. And you can hear it. Well, since there were no seals, I think maybe the tweeters were repaired. There was a resonance at the top, but it's hard to say. But it's clearly visible that there's a serious problem here. And for those who say, well, that's not going to happen, the S-90 here needs to be restored. Nothing needs to be restored. Everything needs to be thrown away. It's old stuff. You can spend a huge amount of time and it will still sound lousy. Today, technology has just moved so far ahead. If we can replace the mid-range and tweeter, then everything will be fine. This repair is going to cost something. I don't know how much. Yeah, guys, let's throw it away. For those who want to replace the S-90 woofer with another one for various reasons, well, there aren't many options within a reasonable budget. But basically, mainly because of the internal volume, which is only 45 liters in this speaker. You can see that this 10-inch woofer we have here is working almost like it's in a sealed box. It has a pretty smooth roll-off. When we move it closer to the wall, yes, it will perform better. But basically with modern speakers we can get a very efficient system where the bass will be deeper and clearer. If we use this Dayton 8-inch, it's quite inexpensive, only 59 euros. It's basically twice as powerful, and if you replace it, well, it's mechanically difficult to replace. You need to make a thick special front panel to put it in the same place as the 10-inch one. But it will play really, really well. If you look at the data sheet, look how little it drops at low frequencies. It has good sensitivity, it has good sensitivity, low resonance. It has 2 coils. We can drive it with 2 channels, 8+8, or get a 4 ohm load, or drive it with 2 amplifiers. Well, overall, it's also not a bad replacement. But of course, again, it's 100 there, 100 there. You can buy a new one. But basically, it can be replaced. Somewhere in the literature, we read that this loudspeaker is a bit too big for this cabinet. But if you make this cabinet bigger, then you can't put it in a small apartment either. The price will go up. And basically, it's a compromise. It was made some time ago, and in fact, this woofer sounds quite pleasant. What are we going to use to replace the mid-range? We have a specialized mid-range from SB Acoustics, a 4-inch one. SB12 MNRX 25-44 ohm impedance. This is a very good speaker in the price range of about 60 euros. And it sounds great. Why isn't it more expensive? Well, because it's already a good one. If we drive it directly from the amplifier output, it will sound incredibly good. This loudspeaker is also excellent. It has a wonderful response, plays very flat, all the way down to 100 Hz. So there's a tiny dip at 1.5 kilohertz, but nobody will hear that. Basically, if you average out the response, it's plus or minus 1.5 decibels. Also, all the parameters are excellent, very good. And it handles 50 watts. Oh, come on. The sensitivity is about 2 decibels lower than the tweeter. We can check what the sensitivity of the tweeter is. And it's 92 decibels, so we'll have to lower the highs a bit, but in active systems that's not a problem at all. We just reduced the sensitivity, that's all, but with a passive filter we'd have to do some serious adjustments. You'd have to install an attenuator there. But usually it's a resistive divider. We'll replace the tweeter with this kind of dome one. It's inexpensive. I could have used this ring-shaped one, but for this speaker maybe that would have been too much. It's about 15 euros more expensive, but still around 50 euros. And this kind of tweeter is very good. You can see the type, yes, SB26, such as STS-IN, C0004, SB Acoustics. Neodymium magnet. Basically, it's a good tweeter. It handles 100 watts. Can you imagine how far everything has come? It handles 100 watts. Naturally, you'll need adapters for each one. So, for the high frequency one, we chose this model. And basically, it measures very well in that range. Basically, if we cross it over around 3.5, it's at 0.1%. Overall, it measures very well. Minus 40 is 0.1%. Overall, the tweeter is 0.1% everywhere. That's lower than the distortion we can hear. The linearity is quite good. But overall, everything is fine. Well, to put everything together, we need some tools, and I spent quite a lot of time on that. I recalculated everything first, and I made these tools on the CNC machine, so that it would be easy to modify this speaker. So everything would sit at the right height for the tweeter. So 2 times 2 millimeters. I didn't have any other material. But like this, everything will be fixed in place. There's nothing too inventive here. Well, there were absolutely no mistakes with the high frequency part. Everything we calculated theoretically turned out exactly as expected. Just like this. A new tweeter. Everything fits. But if you take the previous diameter, it's bigger. So everything fits, and the front panel is already fine there. Approximately. Approximately the same configuration. It will look the same and be easy to attach. Well, the mid-range speaker doesn't have that kind of load since it's in a protected enclosure. Here we'll manage with just one, with a 2mm flange. But we'll mount it carefully. So that's all. I chose a standoff. We'll do everything properly. Well, it's nice when you work with name brand parts. Everything matches the documentation. I made it on a CNC machine. Everything fits well there. There's nothing you need to trim. That's what we're known for. Well, the adapter is ready. Basically, it can be replaced. The hardest part of this project was making these mounting adapters to mount the modern loudspeakers. Well, and we'll be replacing the back panel like this. There are 4 pairs here. We only need 3 since we have a 3-way system. And that's how we'll connect it. Kind of with a single wire. This also needs to replace the back panel. This plastic plug will be replaced with a 2mm aluminum plate. Well, like this. This is what the plate looks like. Everything is done neatly. It will withstand the entire load. That's what we needed for the upgrade. So we have 3 adapters. 3 devices, the back panel, tweeter, and the mid-range speaker. Well, let's put in the new ones. So I've installed these terminals here, crimped. And there's also a question here, so which is better? Soldering or those push-in connectors? But basically I would say that the push-in ones are even better. These good ones are also used in the automotive industry. As you know that there's dampness and frost there, and everything shakes, and there are strong vibrations. In general, they make very good contact. Well, one is positive, one is negative. The bigger one is positive, and the smaller standard one is negative. In general, if they are fixed like this, the contact is good, vibration resistant. In general, everything here is good and well done. Alright, let's put in the rubber gasket so it doesn't let air through. The woofer is working pretty hard here, and not in an open enclosure. Everything needs to be sealed up. Well, let's see how this whole decorative panel fits. Excellent. Everything fits. There's absolutely no problem with the tweeter. Perfect. To avoid stripping the thread, we'll use it carefully. Well, first I'll set it lower to 3. The tightening force. Well, everything is very decent. I'll check it by hand as well. Yes, everything is great. Well, it's a bit more complicated with the mid-range drivers. Well, we've threaded it through. We'll seal this hole with hot glue. While the hot glue was heating up, I soldered the woofer. So, if you look at the original loudspeaker, it already has these protrusions molded into shape. But we'll solve this quite easily. With this 6mm nut, it fits just right in size and is pretty easy to install here. I could glue it too, but I'm not going to do that. We do this once and it'll last a long time. It turns out that these are the 6mm ones with the Teflon gasket. They fit perfectly. And at the same time you can adjust them a little bit and they fit almost perfectly into place. So we remove the excess. The wires closer to the exit. We put the damping material back. It fits here just fine like this. And we put the woofer back. The woofer's gasket is still in perfect condition, so we got really lucky. Okay, here we need some modeling clay so the grill doesn't rattle. So we need to put everything in correctly. This is how old modeling clay seems to lay on the tables. There's so much you can do with children's toys, right? Well, we carefully screw in the small bolts here. I won't even use a power tool, just so I don't strip the threads in the wood. That's easy. Well, that's it. The speaker replacement is pretty much done. Now all that's left is to finish it up. The ends. In general, this ceramic stuff is incredibly nasty. You can get dirty in no time. I put on gloves, otherwise everything here would get dirty from start to finish. But it turns into such wonderful rubber. That's exactly what we really need. It doesn't wash off. Basically, if you get this stuff on you, it's a real mess. There will be a perfectly adequate seal. If we screw it on tightly, it will be perfect. Connect everything and screw it onto this sealant stuff, like that. The standard was chosen so that the first is the tweeter, the second is the mid-range, and the third, sometimes the third and fourth, is the woofer. If we have two coils, you can set up the system so that the channels, the amplifiers work on one speaker, and with a low power amplifier we can double the power. It's all simple here. The ones closer to the center are the positives, and the ones farther from the center are the negatives. For high fidelity, I also put on insulating tubes. Well, if you look at it philosophically, as I see it, is this the speaker of the future? As soon as we install a passive crossover into the speaker, we have big problems overall. We have many problems, and with electronics advancing, there's little we can do. But if we make the speaker empty, just a box and loudspeakers, and connect all the loudspeakers directly to the output, we get an opportunity. To modify the crossovers without disassembling the speaker, we can control it actively, which I think is the best option. This is a step towards better quality in the future, because as soon as we control the speaker directly, that's it. These are the best qualities you can possibly get. And our requirements for amplifiers drop dramatically, because it's such a simple load when we have only the speaker. It has an almost flat impedance, especially in the highs and mids. Yes, the woofer has a resonance, but even the woofer can be driven by a pretty lousy amplifier as long as it has enough power. We can use professional amplifiers. Yes, they're a bit bigger in size, but we can use, say, a 500 watt amp, and it'll be reasonably priced. But if we need an amplifier that works across the entire range, yes, it has to be very high quality. It's hard to make, and there are a lot of different requirements. And basically, it turns out that even the S-90 can actually be turned into something pretty good. Well, yeah, the woofer could have been a little better, but it's not bad compared to the other speakers. It's still a good woofer today, a good subwoofer type woofer that plays deep and accurately. But it's expensive, yeah, it's easily 250 up to 250 euros each. That's where the good ones start. And those that cost 60 or 70 are kind of worse, but they still can be better than the one here. In general, with this configuration and the S-90, you can really make something great. And in the second part, we'll show how to set up a professional active crossover without using measuring equipment, and we can get an almost perfect result. To the listening position. Watch the second part.
Guntars, you did an excellent job of turning the S-90 speakers into a beautiful new version. When you look at them, it's impossible to tell they've been modified at all. But you mentioned some scary words. Active crossover, adjustments, rewiring. What is this? How do you deal with it? And how? I've never connected this much audio before. How am I supposed to figure out how to set up the S-90?
Сегодня у нас лабораторная работа. Включить. Нету там я преподаватель, ты сдаешь частота баса. Ну, не экзамен, ты сдаешь эту лабораторную работу.
I wasn't prepared.
No, you should watch my previous video about how to choose a speaker. All the theory was there. You told me that you watched it.
I watched it completely, yes, 100%.
So, you're prepared.
I didn't take notes, and listen, I didn't even make a cheat sheet.
Why do you need a cheat sheet? This is the most important concept. Yeah, well, baffle step response, what's it called in Russian?
Terrible words, I'm already trembling.
The front panel, the middle of the front panel, how does it affect the low frequencies? I forgot the Russian term. Well, baffle step response was one such important thing, and today we'll go through all the parameters in detail. And what have I prepared? Many enthusiasts don't have measuring instruments. With measuring instruments, everything is simple. But without instruments, we can tune it better.
How do we do it without instruments?
And we'll go through the whole methodology. Well, first let's assess your, audio knowledge as an enthusiast. Do you consider yourself a technical person?
Absolutely not. Right away, that's a 10. I'm not a technical person.
Second, can you buy the equipment and connect everything like the interconnect cables and set it up completely without any help?
I can buy a streamer, an amplifier, speakers, and connect everything. But if you give me that terrible thing with so many knobs, lights, and all sorts of labels, plus a bunch of wires in the back, I'll say, guys, what is this? What is this thing?
No, but what if it's this?
It's some kind of internet router.
No, if you can do it without blocks. This is an interconnect cable, which means we'll cover the whole distance.
Okay.
Second question, here we are in a room. It's a 3 by 7 meter room. And basically, a lot of users who live in post-Soviet 5-story, 9-story, 12-story buildings and so on have rooms like this. There are standard layouts. So the goal today is also not to take a very well-treated room or anything like that. Can we get at least a decent sound in such a completely untreated reinforced concrete room? So, regarding the room, what it's treated with, whether it's treated at all. For example, clap. The clap doesn't reverberate. And for low frequencies, this is a completely empty room. You see, there isn't a single sofa, not a single bulky piece of furniture. This is the industrial part here. And it turns out that for low frequencies, this is the worst room you could possibly imagine. So the ceiling is low, all the walls at low frequencies, they're bare. And we have to get good sound in a room like this. That's why we'll only place it in one position. That's along the narrower wall. Yes, we'll be sitting facing the narrow wall.
Okay.
Because there's no other way. In a room like this, if we arrange it differently, it just won't work. We can talk about that. It's one choice that limits everything. That too, for those who want to get good sound, you need to agree with your wife and rearrange the furniture. I would do it like this, for example. If we have speakers here and there are 4 doors in this room. See, 4 doors. There's one here, one there, one over there, plus an exit to the balcony. So we can just carefully plan how to arrange the furniture. I would put a long sofa here and a 50-inch TV here. And kind of divide the room into 2 parts. And then we'll have great sound, great TV, and we can lie down on the sofa there. So, there's a corner one there, here in the middle, and here there's a passage on the left. There are no other options. If we compromise on placement, there won't be good sound in a room like this. No options.
Ja.
So, here's what I've prepared for you.
Так.
Since we have such a bad room, we'll go over the theory first, and we'll do the actual adjustments while listening to the reference on good headphones. These are good Sony headphones. Even though they're old and wireless, they're not Bluetooth, they're wireless. And when we put them on, we isolate ourselves from the room. That means all the modes, all the reflections, they add up correctly. And if we set this crossover to match how these headphones sound, they'll sound very accurate. Yes, measurement won't provide that. According to measurements, if we do basic measurements, like without an anechoic chamber, but here we have an echo chamber. Very echoey.
Moderately echoey.
Well, for low frequencies, it's basically an echo chamber, because in normal rooms you at least have a couch, you have some bookshelves, you have some irregular shapes. Here there are just two flat tables, and that's it. This is the worst kind of room for bass. It's empty. So this is an active crossover. It has a lot of knobs.
The same one, right?
The same one, yeah. So how are we going to do it? All your knobs, when we start, should be turned all the way to the left, because there won't be any cheat sheet. Everything should be set to the far left position. And we'll go through each knob, and where necessary we'll do the calculations. These are simple calculations. You've already studied this theory. And then we'll adjust it the way we think is best, and then we'll start listening.
Oh, the computer is giving a signal. It's time to start.
Yeah, we got a signal from the computer. Everything is connected here, so how are we going to do this? There won't be more of our faces there, but you'll see the equipment instead. I'll be guiding you through each knob, explaining what each one does and how it works. We'll look at the calculations and also add some visuals, like a few graphs and some basic concepts. Okay, yes. And we'll just go through the entire methodology. We'll explain the whole methodology. Understood?
I'm scared. I'm already scared. Guntars is quizzing me.
No. This won't be an examination. We'll be learning together. Then everyone will be able to do it. Because...
Great, okay.
What's good about this kind of architecture when you have an active crossover? What do people usually say when they modify the S-90, like you need to replace the tweeter with a better one? They say you need to redo the crossover. That's a big job. You need to take several measurements there. It's too cheap to do that. Yeah? Moreover, you also need to have various capacitors and coils available there. Even with calculations, you still need to experiment, so one modification like this is impossible. But here it's simple. Just adjust these potentiometers and it's ready. It's better than a passive crossover. So here we have Linkwitz-Riley filters, 24 decibels per octave. In a standard speaker, it's rare to have more than 12 decibels per octave. On the S-90, the tweeter has 17 decibels per octave, but that's forced. Since the tweeter has a high resonance, it still doesn't cut off well there. Yeah, it doesn't cut off well. Alright, let's get to tuning.
Let's do it.
So here's the principle behind the method. First, we'll set up one speaker for sound balance. Well, so that all the drivers work properly. Okay, let's go through it. The first button, the one on the far left. Yes, that's the sensitivity. As you can see, there's a 0 in the middle. If we're using modern equipment, we set it to 0 right away. Turn it to 0. No, 0 is in the middle.
0 in the center. Done, set to 0.
Next. This is a separate crossover on between the woofer and the mid-range. And now let's recall the theory. Do you remember this baffle step response? Basically, we have one frequency at which the speaker transitions from 360 degrees of radiation. When it's very low, like 50 or 100 hertz, about 3 meters, it's a point source, yes. And at certain frequencies, it only radiates forward.
I remember that.
Yes, and we need to set the crossover at the baffle step frequency. And it's determined by measuring the front panel. For the S-90, it's 36 centimeters.
Yes.
And I gave this method a formula. Let me pull it up on the screen. Well, basically, this is the theory of baffle compensation. In Russian, it's called baffle compensation. And let's take a look at the formula, yeah. 115 divided by the width of the front panel in meters. If we divide 115 by 0.36, we get 320, yeah. So the crossover frequency is 320. Then we can change it, but if we place it close to the wall, then we'll do all this compensation just by reducing the sensitivity, that's all.
So our woofer will play from 0 to 320, and then the mid-range kicks in, right?
Yes.
Okay.
Next, we need to set the crossover between the mid-range and the highs, okay?
All right, this one.
Yes. Here are some thoughts when we had it. The original tweeter had a high resonance frequency. Well, I don't remember exactly, but it was somewhere around 2 kilohertz, I think, or somewhere around there. And then we have to set it high. But this one is modern and good, and the tweeter will work better if we phase it somewhere around 2.4. At 2.4 they will be well phased, yes, they will. That's the second one. Well, 2.4, yes, somewhere around there. Then you can tweak them and see what sounds better. But since all the filters here are 24 decibels per octave, it will cut off those resonances. This tweeter has a resonance at 950 hertz.
Okay, good.
Modern. That's the big difference between the past and the present.
Okay.
If you have the original tweeter, you cut higher, then I would say somewhere around 3.5 to 4.5. Well, wherever it sounds better, yeah. Because if we leave all the original drivers, then we need to make this correction. But if you replace them with modern ones, that's the best. Delay. Look, the next button is delay. This is for professional applications. And when we have a big subwoofer with a horn-loaded design like that, it's in the back, yeah. And in our case, the difference between the mid-range and the woofer is about 3 or 4 centimeters. So 3 or 4 centimeters is about 0.1 milliseconds. Just a little bit, yes, it's all in milliseconds. We adjust it a little bit, 0. And there are those, you can feel how they are.
Yes, well, I moved it 1 click.
That's 1 click. You can also leave it at 0. It doesn't really make any difference. But then we'll end up delaying the mid-highs and the bass will come in at the same time.
Mm-hmm.
Otherwise, with all speakers, the bass is always a little bit delayed.
Yes, that's a well-known problem, and it causes muddiness.
Well, yeah, but in this regard, it doesn't really affect much. If there were digital filters, you could set it up very precisely using measurements, but you can't do that without measurements. And now we have 3. 3 sensitivity buttons. First, set it to 0.
This is our low output.
We set everything to 0, right?
So mid output and high output.
And now we need to look at the speaker specifications. Let's look at the tweeter. This tweeter has a sensitivity of 92.5 decibels. And what about the mid-range? Let's look at the mid-range speaker. So the mid-range speaker has 88.5. We need to lower the high output by about 3 to 4 decibels relative to the mid-range. Leave the mid-range at 0.
The mid-range is at 0.
It's weaker compared to the tweeter, and we lower the tweeter.
High output is the tweeter, and we lower it by 4 decibels.
4 is too much. Let's set it to about 3.
To 3, right?
Like this.
You like the highs to be brighter, right?
It's one thing to have specifications, but all speakers, even today's, have some variation. We'll adjust that later while listening with headphones. Here we're just setting it more or less. And if you see down here, there's a 6-channel amplifier. In this particular case, there's an additional woofer adjustment here. So we can set it here so that on the crossover controls, it's almost at 0. There's an additional adjustment here, but it might be that there isn't one here. Then we do everything on the crossover, so we've set everything up here. And let's set up the second channel about the same way now. You don't have to show it. No, leave the first one because you...
Well, I'll show what we have here.
Well, go ahead.
Everything fits. Okay, here it's at 0.
So we have 2 more buttons, see the ones that are lit up.
Yes.
25 Hertz, sharp. Cutoff. Well, what do you think? Should we use it or not? Or do you want it to play lower?
If only I understood 25 Hertz. 25 Hertz. Well, I'd like to make a smooth cut at 25 then, if that's possible, so it doesn't cut sharply, but smoothly. So it's natural, realistic. Is that possible?
Well, what do you think? Where is the lowest note in the music, approximately?
Well, if someone plays 30, that's already good.
Well, 35. I'd like the cutoff to be at 35 and steep. Then the room won't boom, it's too low.
Well, as you wish, all right.
Now it already buzzes when it lights up. So we cut at 25 because sometimes there are different sources and you can see how the woofer just moves. There's no sound, but it loses linearity. Yes, these lowest ones, God knows where they come from.
Noises can come through.
Let's cut. There are other types. DBX has 40 Hertz. Also, it rolls off pretty sharply there. Then we'll have a clearer, better bass in such an untreated room. So we cut here.
All right, good. We need to...
They pressed it. No, it's here. Yes, here. This button, see?
All right, yes.
This button, low cut.
Got it. And here we have the same one.
We have this one, yeah. Let it stay lit.
It's separate. Let it stay lit.
Yeah. Well, those who are picky and say that if there's no 25 Hertz, then I won't listen at all. They just don't turn it on. But I recommend turning it on. There's no music, just our bass frequency getting distorted. What other buttons do we have? We can invert the phase. Yes. But when we don't measure, then we don't mess with phase. But it turns out that if you reverse, for example, the polarity of the mid-range driver at the crossover frequency, there will be a deep dip. And we see a deep dip better than a peak. That's why it has the ability to quickly switch the phase for tuning, yes. If you forget, the soundstage will be affected. Yes. And since all the filters are the same, 24 decibels per octave, you don't need to reverse the polarity of any of these drivers. In a standard crossover like this, we have a second order crossover on the low frequencies and a fourth order on the mids. 4 reactive elements, and the phase is flipped an additional 180 degrees. Here, everything is fine. And overall, the S-90 has an interesting crossover where the woofer is connected in reverse polarity. The mid-range driver is also in reverse polarity, only the tweeter is in normal polarity. It was probably hard to adjust them so they would sum well. Then we also have 3 buttons. Yes. We can turn off the driver.
What does it mean to turn off the driver?
We can turn off any of the speakers with just one button. They won't receive any signal.
I see.
Yes. Well, let's turn off the left channel and listen to the right one. We'll start with the right. And now I'll play some music with a deep male voice. And then you'll listen to it with headphones.
All right.
And then you'll adjust the bass and treble, not the mid, just the bass and treble until everything is balanced. All right, because that deep voice falls around the crossover frequency, somewhere around 500, 300 Hertz. It doesn't matter what music you use, you'll cut it out later. We'll get banned. Now I'll play you some dumb bass-heavy music. Very dumb, primitive. There will be...
Blah, 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 da?
And you'll feel the bass there. You need to turn it up, turn it down, see if it's okay or not.
But I would leave it like that.
Alright, so there's one feature here that I want to point out. The S-90 has a loudspeaker that's designed in such a way that built for high output, and it drops off sharply. At low power, it's very difficult to set the bass because it gets dampened very quickly when you have little power. It's not linear, and basically it's designed for a room of about 30 square meters. And that's a nuance of this speaker. Modern speakers are much easier to adjust, so you kept turning it back and forth. When there was bass, you wanted to tweak it a bit, then back it off again. That's the peculiarity of this speaker. And if the room is bigger, it will be almost at zero. You'll have to listen a bit louder. Unfortunately, you need to turn it up.
Yeah.
So, well, you've set up one speaker. What we're going to do now is set up the second speaker, and how we're going to set it up.
Should we copy the already set up one or set it up again?
We're listening. Because speakers are not 100% identical when they're made, there might be a decibel difference, so we don't set them the same. We set them so that you can hear clearly. In the center, there's a balance between the mid and high frequencies. And then what do? We turn off the highs and lows. Right now, this is the mid, highs and lows. And on the left speaker, we connect this mid right now, just the mid. Now you need to sit down. Now you need to sit in the center and listen so that the male voice is exactly in the center.
So I'm adjusting the mids, right?
Or you adjust the mid on the left speaker, this one, the mid on the left speaker. It's the same with the highs. You balance them with the left speaker, but that's how the technique is. Yeah, so that they're centered for me.
In the center, my left channel is weaker in the highs, so this adjustment is for me.
Now connect the woofer and listen to how they sound together. And connect it. Well, basically you've set everything up, right?
Set it up.
And then, well, an average person will reconfigure it another 15 times. But the principle is the same.
I would also run it a bit more.
But they're different. But in general, you find some really well-made mix, yeah, where everything is done properly and neatly, and based on it, well, who knows? Maybe they tuned it a little one way or the other.
The main point is that you like it. That's what we're adjusting, right?
But the soundstage being centered, that's not about what you like, that's later, so that it's centered. Well, then it should be the recording that's done with good quality. You adjust it so it's centered. Well, basically everything is done. I also wanted to show you why people become dissatisfied with the system so quickly.
Maybe we should sit back down then.
No, you need to listen here. This will be without your listen. I'll show you an experiment because since you have to sit and listen, let's play the same melody again. Let it play there, then we'll listen to yours, the one you sent, but I want to show you an experiment. Turn off the mids on both to create a dip, and we'll listen to about 2 songs without it. Now you connect the mid, and the first impression is to connect both mids right away. So the experiment was a success. That means what we had was a perfectly balanced signal, right?
But we balanced it ourselves for everything afterwards.
And it was balanced across the frequency range.
We had the mid frequencies turned off.
And what did your brain do?
But at first, when I listened to Ash, it seemed pretty dull to me. But the second song seemed quite decent and listenable. And then, when we suddenly turned up the mids, I already wanted to turn it off. I started to feel uncomfortable. The mids just overwhelmed me. I would say that yups today.
Yeah. So, if we have a two-way speaker, they have a dip, and those who measure say that it won't sound good because of that dip. That would be complete garbage. We have a DSP inside that can fix this. And we'll feel that it has been fixed when we just set everything to 0. I made this new extreme version and saw how much it was sticking out. After your brain makes corrections, it works just like your eyes do. You put on blue glasses there. At first everything was blue, but after 5 minutes it balanced out, and it's the same with hearing. That's why when we listen to something, analyze it and do something, it's a very complicated thing. In general, we can always be dissatisfied. Something will be a little off, maybe something with the mids, or someone bought big speakers. The woofer sticks out there and you can't get rid of it, and your brain tries to make a correction. And when you go to the store and listen to a properly balanced speaker, you think, yeah, this doesn't sound right, there's no bass at all, no bass at all. But at home, I have speakers with real bass, that's what you think. But in reality, that's what you're hearing.
Ну, нехорошо.
It's not good, it's distorted. So what do the salespeople do? They say it needs to be warmed up, or whatever the right word is.
Take it.
Take it for a week, warm it up, then it will show you what it can do. Basically, that's what the seller does. The seller makes you balance your hearing because when you listen to those very low, tight speakers, your sense of balance is completely thrown off. As for the lows, I don't know about the lows. I'll show you another experiment. I'll show you. Now let's listen at low volume and to some dumb music, but with a bass that's like thump, blah, and then I'll turn up the volume, we'll listen, and then I'll go back to the previous one.
Okay.
Yeah.
Well,
here's the idea. Years go by. Basically, your ears adapt and they usually recover in about half an hour. You can switch it off, listen to one song with different bass, hear how it sticks out, and your ears still will not recover for about 30 minutes. And when you're completely fresh, you come in, set it up, play some quiet music at 70 decibels, and the bass is balanced, and everything sounds good. Basically, we can be fooled in different ways. Our hearing is that sensitive.
our hearing is actually a very interesting thing, and it adapts very quickly. And it loses sensitivity, yes, if you turn it up all the way, 235 tracks.
Yes, it comes back in half an hour.
This is because we have tiny hairs in our outer ears that transmit the sound signal further. And as soon as we apply a lot of sound pressure, high volume, they start to bend, and then they slowly return to their original position. So, when they bend, they protect our hearing from overload so that we don't go deaf. And if you listen to music loudly for a long time, these sensitive hairs eventually don't want to stand up at all.
Well, you might lose your hearing completely. And how does that show up? So, I bought good speakers. They sounded great. I liked them. I listened to them. Listened for a while. One day I like them. The next day I don't. The third day I don't like them. I start adjusting the tone controls and something else. And you also have to keep in mind that some tracks are recorded with compression and a plus 6 decibel bass boost. And if you play something from the 50s, they'll say it's terrible. Let me play you something from the 50s. It's rock and roll. It sounds like a bucket.
You don't have to play it, I heard it this morning. The sound quality is really bad. Back then, they couldn't record well. They just recorded however they could, and that's why it sounds like that.
Yeah, and now you can just listen to your own music if you need to make any more adjustments. You sent me these tracks. Listen to the ones you like. And then we'll draw some conclusions about how good we got this speaker sounding. So basically, what did we do? We set everything up and then listened. Can you share a bit about your personal impressions, like how difficult it was?
Well, the first times I turned the knob were basically meaningless for me. I turned it one way, then the other, but after your explanations I understood the point. Yes, basically, if you adjusted the same way, just watch the part of the video where we turned the knobs a few times to understand the principle. And then, by ear, it's quite possible to tune the sound system yourself. And you know, after all these adjustments, the sound turned out to be very interesting. I didn't even realize my listening preferences for tuning speaker systems were so different. Because usually, when we go somewhere to listen to something, they turn it on, we listen, well, it sounds the way it sounds, you can't really change much. Well, okay, there's an equalizer, you can tweak it a bit. But here, everything works differently. You adjust the highs separately, you adjust the mids and the bass separately. And it turns out that my sound preference is a little different than I thought before. Overall, it's interesting. And it sounds good. It sounds really good.
But the method itself, when you listen with headphones and do this sound balancing, is it easy or not so easy?
Well, you just need to do it a few times, and then you'll start to understand basically what you're doing and why. Yeah, and then there won't be any difficulties. But like with anything you do for the first time, at first it's not always clear. Do it a couple of times, a few times, and everything will start to work out.
Why do you need to tune the speakers to match the headphones? This room, as I said, is a very bad room. Everyone has a better one than this. This is the biggest room you can find. Except for one thing. If you clap your hands, there's not much echo reduction here. Yes, that's it. That's the only thing that's been done. But for the low frequencies, it's really bad. And it turns out that here, when we listen in this room, we hear a mix of reflected and direct sound. There's no other way. The ceiling is low, the floor is flat, and the walls are flat and untreated. But basically, as you said, it sounded pretty good afterwards. A completely untreated room.
Yeah, it sounded good because all those reflections bouncing around here, we correct for them here.
Yeah, when you're tuning an anechoic room, yeah, you can end up with some artifact, but it's fine, you just fix it.
Well, yeah, then it'll be flying all over your apartment.
Yeah, and in such a small room, you can't really move far from the wall to dampen the first reflection, especially when it's cancelling your bass somewhere around 100 Hz. You have to move it almost, well, more than a meter away from the back wall. And you don't have the space.
But we all live in such conditions that we don't build our apartments around speakers like, well, that's how audiophiles are supposed to do it. We put the speakers in our apartment wherever we have space to put them.
But in this case, if you put them anywhere else, I experimented with this, you can't get the same quality. No way. Because the way it's set up here, there's a THX standard for how to build a high-quality home theater. And you have to, well, there's a screen on the wall, the speakers are close by, and you sit about 2/3 of the way into the room with a large open space behind you. They're scientists. They've already worked this out with furniture, and that's how it should be done. I think it will be hard to agree with my wife on the renovation and the panels, but as for adding some furniture, we can probably come to an agreement.
Well, it's possible, it's possible. You can agree on the panels too. The main thing is that the panels are nice, not that awful foam, you know, the ugly kind. Well, talk to your wife, see what she likes. There are different shapes, different colors, different shades, and different styles.
By the way, decorative pillows work really well, especially if you sew them in blocks of 6, yes. No, it works well by every acoustic principle. First of all, if you place it so that there's another 5 centimeters of space behind it, it works much better than if it's pressed tightly against the wall. It's thick, yes, the cushion is at least 10 centimeters thick, maybe even more. Overall, it works. Compared to it, foam rubber is nothing, and it's environmentally friendly. All those that absorb should have that kind of fiber structure.
Sure.
A fiber structure. And how is it absorbed? When the wave hits the fiber moves and heats up, and the energy dissipates. That's why these fiber structures absorb well. You can't use anything else there. Another option, diffusion, is also good, but in a small room, those are large structures. There are no other options here. But in principle, we installed it in a very bad room, and it sounded more or less okay.
It sounded good, not just more or less, it sounded good. You can also, if you spend more time, tweak and adjust it even more to make it sound right.
Even better, choose a very high quality recording.
Well, you need to choose different recordings. You need to choose both high quality and low quality recordings. You need to hit the middle ground between good and bad ones. Otherwise, you'll need to adjust it every time. Find the middle ground. But that's my opinion.
Well, in any case, when you're taking measurements, but with a good recording, you need that deep male voice. Because the blend between the woofer and the mid-range is important. If you make a mistake there, it will sound a bit off. We didn't do one experiment, but I recommend everyone to find a BBC documentary on YouTube. The BBC is obsessed with sound quality. And listen to the speech so that there aren't any sibilants there.
Sibilants.
Sibilants, yes. And then also carefully adjust the highs so that they're enough but without any sibilants. That's easy, but many people like to boost the highs a little bit. And the quality of speech determines how good the speaker is. If such a large speaker is very clear when it comes to speech across the full range, we trim the range based on that speech. That's easy. But across the full range, then we know that the mid-range is good. The mid-range here is good.
The speakers sound good. I really liked how you modified them. They look really good visually. They're not distinguishable from the original, well, from a close or medium distance. And in terms of sound, they became much better than the classic S-90 speakers, because after all, there are new drivers, good filtering, and an active crossover. That makes a difference.
Well, yeah, when each speaker has its own amplifier. Then here, in this system, the low frequencies are completely separated from the mids and highs. So for the lows, when they're pumping, the power supply might sag, but the mids keep playing.
Smoothly?
Smoothly, especially those who love heavy rock. They have a problem that when the bass kicks in, the mid-range turns to mush.
It's lacking punch. Oh, it's lacking power. It's lacking power.
Well, that's a tough task for the amplifier too. First of all, it's already used up its resources on the lows. It needs to deliver microdynamics in the mids, but it's already tapped out.
But what we get is that the amplifier has a tough job. With one hand, it has to lift a 16-kilogram kettlebell up and down. That's how it pumps the bass. And with the other hand, it has to take miniature tools and do mechanical repairs.
Play the piano, yes.
No, repair mechanical watches. Just imagine, here he's pumping out bass, and here he's repairing watches. That's how realistic it is to do all that. Just do some experiments, then write a comment about how it worked out for you. And here's a good amplifier with proper power supply and solid engineering. It can do that. It can be both delicate and powerful.
But it's a difficult task if it's not going to be cheap.
That's for sure.
And when you split it, for each amplifier, the task is very simple. You can take, I don't know, a PA amplifier and connect it to the low frequency channel. It will play just fine. But if I use it for the full range, it won't sound good. And you can use a low power, good, clean, excellent amp for the mids and highs. That's why I think the next step is a different architecture. Multi-channel architecture is becoming cheaper and cheaper. And you heard that even the S-90 can sound good, even with the grills left on. Everyone who says if you remove the grill it sounds good, but with the grill it doesn't. Everything sounded fine.
Everything sounds very good. Even in an untreated room. Well, thanks to the tuning.
A different architecture.
If you don't praise yourself, no one will.
It's a different architecture, not a new one. So you can make the S-90 into something great.
Okay, good. Alright guys, leave your comments. This was Arkady Zenin from Premium Hifi and Gunter Schmidt from TC Rasters. Our contact information is in the description. If you have any questions, ask us, write to us. Most importantly, like the video and subscribe to the channel. And may the force of the sound that's right for you be with you. Come visit us. See you next time. Paulus Guntars.
Paulus.